Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.7-3.9, Review B. Let's go ahead and get started. Directions for the first 6 say to graph the inequalities and write the solution set in interval notation. Let's go ahead and look at number 1. What's wrong with number 1? Where's the variable? Yeah, it's in the back. We have to rewrite this, okay? So when we rewrite it, the x comes first and then the 3. And who's the inequality pointing at? Yeah, it's pointing at the 3, so when I rewrite it, I need to make sure it is still pointing at the 3. Okay, now let's go ahead and graph this. Remember, when the line is underneath it, we have to close at 3, and it's greater than, so we shade to the right. Now, as I write that in interval notation, our graph starts at 3 and it's closed, and it goes to positive infinity. Okay, number 2. So when we're looking at number 2, we just need to pay attention to the symbols, okay? Because the x is in the middle. Our first symbol is open and our second symbol is closed. So at -4, I'm open. At 5, I'm closed. And this is an AND graph. And when we're talking about ANDs, we shade the middle. Now writing that in interval notation, our graph starts at -4. I'm open, so I'm using parentheses. And then I'm closed at 5, so we use the bracket. Okay, number 3. Now, the first thing I notice about number 3 is that's written incorrectly. So let's rewrite that. So the variable's first, and then we have -1. So our inequality's pointing at the x. I'm going to make sure it's pointing at the x, and I'm just going to go ahead and graph that one. X is less than -1, so I go to -1. I'm open and I shade to the left. Now our second inequality, x is less than or equal to 3. So at 3, I'm closed and I'm less than or equal to that. And there we go. So what is shaded? Well, our graph starts at -infinity all the way to the left. Yeah, that's -infinity. And then it stops at 3. And are we open or closed to 3? Closed. Okay, number 4. Why don't you guys pause the video and try number 4 all on your own. Okay, just like number 3, everything ends up being shaded to the left, and we have -infinity to +2, and it's closed to +2. All right, number 5. First thing we have to do is graph x is less than 3. It means we're open at 3, less we shade to the left. And then we're greater than or equal to -2. So at -2, I'm closed and I shade everything to the right. Now, this ends up being one of our special cases because we start at -infinity and the graph continues to +infinity. All right, number 6. Now, the first thing I notice about number 6 is we have a fraction. And I need to know, what does that fraction equal? So when you do 5 divided by 2, you get 2.5, and just remember that it's a -2.5. All right, so at -2.5, just do your best spot, it's closed. And then at 4, I'm also closed. and this is where we shade in the middle. Okay. Go ahead and see if you can write that in interval notation. Well, it starts at -5/2 with a bracket, and then it goes to +4 with a bracket. Okay. All right, so there's problems 1 through 6. All right, number 7. For these ones, it's asking us to solve, write the solution set in interval notation, but then we have to graph. Okay. So first thing we're going to do is draw the line down the middle and solve for x. So I have to subtract the 6 to both sides because we're following the rules of SADMET. I'm left with -6x is greater than or equal to a +18. And now that x is not by itself yet, I have to divide by -6. And what's the rule for when we're dividing by negative? What do I have to do to that symbol? That's right, I have to flip the symbol, and we're left with x is less than or equal to -3. So my graph over here is going to be x is less than or equal to -3. I don't think you have to rewrite that, but I do just so I know what I'm doing. So at -3, I am closed, and I'm going to shade to the left. So interval notation, our graph starts at -infinity. It goes to -3, and then I'm closed at -3. Okay, number 8. Number 8, we're going to start together, but then you guys are going to finish it on your own. Okay? So the first thing I have to do for number 8 is I have to distribute. Okay? That -12 comes down, and then 3 times x is 3x, and 3 times 3 is 9. And that is less than or equal to 6x minus 3. So the next thing we have to do is combine our like terms. My 3x comes out front. -12 plus 9 is -3. And we're left with 6x minus 3. So the last thing we need to do before I give it to you guys is we have variables on both sides. And we talked how we always want to get our variable to the left side when we're dealing with inequalities. So when I subtract the 6x over there, we get -3x minus 3 is greater than or equal to -3. Okay? So you guys are all on your own right here. Okay? See if you can solve this and then graph it. Pause the video, and good luck. Okay, so did you remember to flip the inequality when you divided by negative? I hope so. So we're left with x is less than or equal to 0. When I'm writing that in interval notation, we have parentheses with a -infinity, comma 0, and a bracket. All right, number 9. Yep, I'm making you do this all on your own. Pause the video, and good luck. Okay, so I distributed and I got 40 plus 24x is less than or equal to -40 minus 16. We added 16 to both sides to get the 40. And now I'm subtracting 40 to both sides to get -80. And then I divided by a positive 40. When I divide by a positive, even though I got a negative answer, I do not flip the sign. Okay? So we're left with x is less than or equal to -2. Okay. Okay, let's flip it over. Number 10 we'll do together. So right away I see that we have two problems here. So I'm just going to kind of break them apart and we solve each one individually. So our first one, we're going to subtract 1 to both sides and we get 7x is greater than or equal to -7. And to get the x all by itself, we divide by 7. I did not divide by a negative, so I get x is greater than or equal to -1. Okay, on the right side, once again, I want to get the x by itself, so I'm subtracting 1 to both sides. And I get -3x is greater than or equal to 12. And now to get the x by itself, I have to divide, and I'm dividing by a, what type of number am I dividing by? That's right, I'm dividing by negatives, so I have to flip the sign. So we get x is less than or equal to -4. Now, when I'm writing both of those together, I'm going to write the smaller one first. X is less than or equal to -4, or x is greater than or equal to -1. So this would be our final answer that we write down. Now let's do the graph. So at -4, I'm closed. It's less than, so I shade to the left. And then at -1, I'm closed, and we shade everything to the right. So as we write that down, in interval notation, it's -infinity to -4 closed union, and then our graph picks back up at -1 and it goes to positive infinity. Okay, number 11. Why don't you see if you can, we'll do this one together. Okay, so I'm drawing the lines down the center, and remember that when we're solving for x now, I'm solving it to 3 sides. So when I subtract that 7, I need to make sure that I'm subtracting 7 to all the sides. -21 minus 7 is actually -28, not -14, guys. And 14 minus 7 is 7. The x is not by itself yet. I need to divide by a positive 7. -28 divided by divided by 7 is -4. And then 7 divided by 7 is 1. So I'm going to be graphing -4 is less than or equal to x, which is less than or equal to 1. Okay, so at -4, I'm closed. And at 1, I'm closed. And with these types of graphs, we always shade the middle. Okay, so for interval notation, close bracket at -4, and then a close bracket at 1. All right, number 12, I'm going to make you guys do that all by yourself. So go ahead and pause the video, and good luck. Okay, there you go. I'm starting to write it in interval notation right now. So I subtracted the 4 and divided by 2, and we get -5 is less than x, which is less than or equal to 4. Okay, so you have to pay very close attention to your signs. Which one's open and which one's closed. All right, number 13. We'll do 13 together. Right away, we see the or, so I know that we're going to have two different problems to solve for. I'm going to draw the line down the center, and then when we subtract 6 to both sides, we get x is less than 4. Well, that wasn't too bad. But let's look at the other one. I'm going to rewrite it just so we have a little bit more room. Now, to get the x by itself, I have to multiply by the reciprocal. All right. Now, if you learn to cancel the corners, you can do that. Or you can just multiply straight across. 5 times 6 is 30. 2 times 5 is 10. And then we can divide that out. 30 divided by 10 is 3. Now, when I write my final answer, I want these in order from least to greatest. So x is greater than 3 or x is less than 4. So that's what we're going to graph. We're going to graph x is greater than 3 or x is less than 4. So x is greater than 3. I'm open and I shade to the right. There's our first one. And now x is less than 4. And then I shade everything to the left. So what would that be in set notation or interval notation? Well, yeah, it starts at negative infinity and it goes to positive infinity. Okay, 14. Once again, there's the or. So we're going to break these down into 2. And you guys are all on your own. Okay, giving you a heads up. Watch out for that negative sign. Go ahead and pause the video, solve it, and graph it. Good luck. Okay, so when we solve the left side, we get x is less than negative 5. Remember, when we divide by a negative right here, we have to flip the sign. Okay? Then we add 6, divide by 2, x is less than or equal to 4. There's my answer. And then here's our graph. All right? Both sides end up being shaded to the left. So in interval notation, we have negative infinity to 4. And at 4, we have a bracket because it's closed. Okay, last one, number 15. You guys think you can do it on your own? Okay. Just be careful with that x because it's negative. All right, pause the video. Good luck. Okay, so as we're going through this one, I added 4 to both sides and then I divided by negative 2. When you divide by negative 2, I had to flip all of the signs. But then if you notice something, where the 2 and the negative 1 are, they are not in order from least to greatest. So we had to rewrite that to negative 1 less than or equal to x less than 2. You had to pay very close attention to which way that inequality is. Okay? So as I'm graphing that, I'm closed at negative 1, open at 2. So there's our graph. And then interval notation, bracket negative 2, parentheses 2. Or bracket negative 1, parentheses 2. All right, guys, well, that's it for Algebra 2, Chapter 3.7, 3.9 notes. Remember, if you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off. Thanks for watching.